The topic today that I'll be discussing is around IoT and the role of AI for better air quality. Here we'll be stressing on multiple data points for better monitoring, better analysis of occupancy, and also ensuring the correct level of purification. How do we achieve it? I promise I'll keep it very short, probably under 4 or 5 minutes. Happy to answer as many questions because whatever we're going to talk about, 7 minutes is not going to be enough. So I'll just be touching upon the topics and I'll move ahead quite fast. Happy to answer all those questions later. So this slide she's already covered. So I'm the founder of Clareco. We've been around since 2018, have presence in around 35 million square feet. I'm also Forbes 30 under 30, and we won multiple different awards. We also have 7 patents, and we're doing a lot of work on air quality and energy efficiency as well. This is a simple air quality device. Many other very good companies are out there who manufacture these different air quality monitors. Some of them are very well calibrated, and the service of many of those companies is very good as well. I'm happy to report that we are also one of them, and we're doing a great job in terms of air quality monitoring. We can measure as much as 13 parameters, but mostly 6 parameters is what we're looking at. I'm just going to talk about the devices and quickly jump to the analytics because that is where the main part is. Many people make devices, that's great, but where is the intelligence? That's the core of my conversation today. First is air quality monitoring. Many OEMs are there that do air quality monitoring. Second is people counting. Why is occupancy data or the number of people in the building important? Because we're talking about ventilation, 52.2 and 52.1. We have to look at people counting. How many people are there in that space? Based on that, we have to understand how much fresh air is actually required in that space. This is where we'll be able to differentiate ourselves substantially in terms of bringing the wellness to the next level, which is at the moment not happening in the way which I anticipate how the buildings should work. What is happening right now, we have demand-based ventilation, where when the carbon dioxide levels achieve, say 1,000 ppm or a 1,200 ppm or a 950 ppm is when they usually kick off. This is a reactive technology. We need to start predicting. The occupancy is a great way of understanding that. By the way, the same people counting can also be used for HVAC energy efficiency, but because that's not the crux of the conversation today, I've touched upon this topic at a different webinar, also managed by a thermal control team. So today, because we're talking about air quality, I'm talking about presence and the requirement to understand the number of people in that zone. That gives us a very strong understanding on how much ventilation is required and what is the air quality there, based on which what all things need to be done. Okay, so these are just data point generators. The intelligence is yet to come. We have simple dashboards. All OEMs have these dashboards where you get different parameters, but this is not where the magic is. The magic is happening in different analytics. Now, this analytics is where you understand that at what time do we have the highest occupancy, hence the higher level of CO2. Now, let's take a question and let's take an interesting scenario. If some of us have lived in NCR and been there in winters, we understand the air quality outside can be horrible. Now, imagine if the indoor CO2 levels are, say, above 1,000 and outdoor PM levels are north of 900. The FM is usually confused, should they still take fresh air? With these systems, with the right level of purification systems in the treated fresh air system, the simple answer is yes. 100% the fresh air systems should be on, even if outdoor air quality is horrible. Because you have a good MERV 13, MERV 14 grade of air filter on the fresh air systems, and you're maintaining a positive pressure in a building, the outdoor dust or outdoor pollutant will just not enter from the main gate or any other openings in the building. Hence, positively pressurizing a building is very important. This is one strong differentiation where Clareco has been able to bring in. We measure pressure as well, unlike most other OEMs where they do not measure pressure. Unless you have a positively pressurized building, the positive pressure can be very low, from 2 to 4 Pascal, right? But still, that small 2 to 4 Pascal of positive pressure can ensure that outdoor pollutants do not enter the building. Otherwise, it doesn't matter how good air ventilation systems in your AHU levels, the air quality will not be maintained if you don't have a positively pressurized building. And we've seen this in so many places across. A quick background about Cleco. We were the first ones to launch clean air as a service, where we charge a monthly fee for promising that and maintaining that air quality. So whatever filters need to be replaced, we've been doing that. So this is something that I've actually done in practice in over 120 large commercial buildings. So this is just not in principle, we've done this at scale. So this is what I'm talking about. Having an intelligent system that measures these basic parameters, understands the fresh air systems, understands the filtration that you have, understands the occupancy levels, and then takes decision on what needs to be done. What should be the VFD setting of your fresh air intake? When do you predict the filter needs to be changed? For example, the same air filter in NCR, where the air quality is much worse than, say, for example, Bangalore, the filter will last much lesser. Bangalore's filter's life will be way longer. But how do we anticipate these things? A good differential pressure sensor is a great way of doing it. Otherwise, by just understanding what is the ambient condition and the indoor condition, also, you can predict when the filter needs to be replaced. And if you're able to predict the filter replacement and you're able to ensure the procurement and replacement happens in time, the air quality will always be maintained properly. This is something that our system is able to do. So we have multiple models, multiple CNN-based models, ANN-based models that we've been able to use to understand and predict these different things while maintaining better air quality. Of course, goes without saying that when talking about air quality, we also have to look at sustainability, and we can't just keep on taking fresh air from outside. So maintaining the right balance with all these different technologies, all of these sensors is key, because all these sensors, as the earlier speaker was also talking about, work in silos, and that's a big problem. And there's no intelligence in checking this. For example, if there's a sudden spike in our sensor, my system will understand that these spikes are happening more often than earlier. And it is not necessarily because of bad air. It could be because of a faulty sensor. So we will send someone to go and check it. So it's also important to take data, make sure you are using a lot of analytics over it, but also take it with a pinch of salt. Ensure that there is something that is doing fault detection diagnostics on the data. So this is something that we've been able to do at Cleco as well.